Hello guys, I'm Peter from Build. I've been looking forward to this video. The backstory is when I started making my cockpit, one of the first things I did 12 years ago was the pedestal, and I went to my local hardware store and I got my hand on some H-shaped iron. And the pedestal is more or less half a meter long, so I needed something that wouldn't bend, and that's why I went for the H shape. And I just mounted rose rails in the pedestal, 6 in total, and everything was good. All the panels I made, of course, I made to fit the H rails. They were about 12 millimeters wide, and that's very important for this video. They were 12 millimeters wide. Then at one point I started buying plug and play stuff like this one. That's metal enclosed on the back side. And I even got my hands on some OEM stuff as well. And now the problems began, because the width here is not 12 millimeters. It's less. It's around 9.5 millimeters. I don't know what that converts to in inches, but I couldn't fit any panel into my pedestal because I had 12 millimeters here on each side, and I only had room for 9 with these. The last video I did was the rudder panel here that I remade, and I ran into the same problem. I couldn't fit it into the pedestal. Okay, this is it. I'm going to make something else. I'm going to find another solution, and that's why I came up with this. It is not a, how do you say it? DZUS? DCUS? SUS? SUS? It's a SUS rail. It's the SUS rail that you use in your pedestal. And the good thing about this, and why this video might be of interest, is 3D printed. I've 3D printed this on my own printer. I have, and in the 3 standard size 22 centimeter printer, and this fits. You can make these with your own 3D printer. How cool is that? It's not a SUS rail. Very important. A real SUS rail that you use for OEM equipment like this has a string on the back here. On a real SUS rail, there's a string of metal going all the way down just in the middle of the holes, and the SUS screw here works by, you push it down, and there are some grabbers here on the back, and when you turn it a quarter, they grab that rail of metal in the hole and holds it in place. So you twist it and it grabs the metal, and that's how it's kept in place. Even if it's in the overhead, it's grabbed on that string of metal going across. This one doesn't have that string of metal. This is made for panels like this, where you use regular screws, M4, and you mount it into this. The way you mount it is by making some kind of thread in these holes. The holes are 3.8 millimeters wide, and I chose that to be able to use a threaded drill like this. You can get these for a few dollars, and this is an M4 drill, and what you do is slowly, very slowly, because this melts, the plastic melts if you do it too fast. So slowly, you just put it down here and you drill your way through, and you end up with an M4 thread. This part I've done it, so let's see, there's a hole here. It doesn't go anywhere. The screw sits in the plastic with the thread made from the drill. That's the easy way to do it. If you want to be a bit more complex, but perhaps also a bit more sturdy at the end, you can use these small brass inserts that you melt into the plastic. If you're not careful with this, the threading is gonna break at one point. It's gonna be ruined. If you're gonna take panels in and out a lot, I'm recommending the brass here. They don't break, whereas the thread made directly in the plastic, well, at some point it's just gonna, if you over tighten it, you're gonna break it. The sides here, this is for each side. Just mount it here with screws, and then it doesn't go anywhere. It kind of clicks together, and it's held in place all the way down here. For the ones in the middle, well, you're not going to be able to mount that into the side of the pedestal. So I've made brackets here that goes on the front and the back, like that. You put that into your wooden structure. It's tightened here together with screws. And actually, if I try to push It bends a little bit, but not very much. And it only bends upwards. So if you put pressure on it downwards here, it doesn't bend at all. But if you're still afraid it's going to bend, or you have something heavy, like a very heavy printer, I've also made these small, what do we call these, towers, then you can mount. And then if you have a tower here and a tower here, you can have a beam going across either that way, or following the rail, or across your pedestal, and that will make sure that it absolutely never bends. And the panels, you can see there are a lot of room underneath in case you have a cross beam there. Oh yeah, if you have OEM things like this with real DZUS screws, you're not gonna be able to use this because it's not a DZUS rail. You can drill a hole about 6 millimeters and then you can slide it in, but it's not going to be fixed. It's just going to be sitting there. The files will be available for download on builderboeing.com. Just search for DZUS, DZUS, DZUS. It takes about one of these sections, half a rail. It's about 5-6 hours of print, so 12 hours for this entire section. That leaves you with more or less 2 days of printing, but then you have your own set of rails. How cool is that? Okay, I'm Peter from Builder Boeing, and you guys take care. Bye-bye.